Okay, welcome everyone. Let's go ahead and get started today. So as I mentioned on Monday, there is an assignment that's going out today. We're going to spend some time talking about that, I think, at the end of class. But just to kind of keep you aware of where we're at, we're going to keep reading through this book for the next 2-ish weeks or so. That'll get us up to roughly spring break, and then after spring break, we're going to get started on the projects. So sometime in the next week or so, I think I'm probably going to take 10 or 15 minutes at the beginning of class and really spell out what the details of the project are. But one thing that I can tell you now that you can start thinking about is that you are going to be expected to work with a group. So if you want to start thinking about who your group members are, the idea for your project is also going to be largely up to you. I'm going to put some restrictions, but they're not I'm hoping they're not going to be too restrictive around what you need to do for this project. One restriction that I think should be fairly obvious is that I'm hoping that you choose Java, right, as an example. You can start thinking about who you want your group members to be and start thinking about what you want your project idea to be. And sometime next week, we'll have a more in-depth, detailed chat about what these projects are going to look like. Are there any questions about calendar stuff, logistics stuff? Yeah, what's up?
How many people per group again?
How many people per group? That's a great question. I would prefer it if you kept the groups to be in the 2 to 3 range. If you have 4 people to a group, I'm probably going to be okay with it. More than 4 is absolute no, not happening. I think 3 or 4 is probably a good target to shoot for.
And a minimum 2.
I think 2 at a minimum, although I would actually prefer 3 is kind of the sweet spot, in my opinion. I think 3 is a nice little sweet spot. If you have fewer than 3, then it kind of limits how much work you can get done on the project. If you have more than 3, it increases the communication that you have to do. So 3 is really kind of a nice sweet spot for projects. Other questions? Other questions before we begin? All right, let's have a chat about this reading. So this chapter of the reading in particular, I feel like is one of the most important chapters in the book, as well as probably one of the perhaps more difficult ones to internalize and perhaps even a little bit controversial, I suppose, in some ways. So I have my notes here from my reading of the book, and I'm happy to share those with you. But I guess I first wanted to go ahead and see how you all felt about the reading, if there was anything from the reading that you thought was particularly interesting or particularly, you very much disagreed with, perhaps, you thought was a controversial statement, anything that you thought was surprising or flat out confusing. I'd love to open up the floor and see if there's anything that any of you felt particularly strong about to kick us off. We're talking about functions today. Talking about coding up functions. Anybody got anything? I know it's 10 o'clock. I understand this fact. Y'all did the reading, right? I hope. See lots of nodding heads. That's good. That's great. Did it sit well with you? Did any of you think that the reading was a bunch of garbage and like, how dare this guy tell us how to write our functions? Or maybe the opposite was true. Did any of you look at this reading and think like, oh my gosh, this makes total sense. I want to do this right now. This is how I'm going to do everything from now on. Or was it just kind of, yeah? Did you have a?
Yeah. One thing that I found interesting was, I guess the chapter talked a lot about what the upper limits of what a function should be were. Like how many parameters you can have.
Yeah.
How many actions each one of the function should implement. But it didn't really specify that much about what the minimum should be. Because a function is a form of abstraction, and abstraction oftentimes comes with the cost of performance. I guess at what level is a function kind of detrimental to what
Yeah.
you're doing?
I think that's a great question. So the question, just to kind of reiterate and correct me if I'm not presenting your view in the way you intended, is this idea of, you know, I think a one big takeaway from the chapter is functions should be small, right? They shouldn't be very large. They should be small as possible. But how small is too small is kind of what I'm getting. Functions do introduce performance hit to use them. It's relatively small, like the amount of performance required to call a function is pretty small, but it's not zero. And so the question is, how small is too small? I think there is too small, an idea of a function that's too small, a function I would consider too small. I think there was one example in the text of a function that they considered too small, where it was basically one of those one-liners wrapping a function call within a function call, perhaps, you know, like just restating the function as another function, I think is a classic example of too small. But my takeaway from the reading, one of my takeaways, and you're welcome to disagree with me, is that while it's very easy to write functions that are too long, it's actually kind of difficult to write one that's too small. It's definitely harder to write one that's too small. And as it relates to performance, I think that's an interesting question, because you consider that actually the book, so far we've only read 2 or 3 chapters. Very little mention has been made about performance in this book, right? Very, very little mention has been made of speed in this book. And I think that's somewhat intentional. This book, in my opinion, and again, you're welcome to disagree, is saying that readability of the code, organization of the code is priority number 1. Performance is a very close second, perhaps, right? Functionality, all that stuff, but it's got to be readable. It's got to be legible. Yeah.
So I guess from the perspective, or at least the audience that the author is trying to write to, is that more, is it in general geared towards more enterprise software developers versus people who would be more concerned about hardware limitations or time-dependent software?
Yeah, identifying the audiences of the book is definitely a concern. I think the author's background, I don't know if you've Googled him, but his background is in the business world, right? So I think he's writing with his own experiences in mind. And he does have biases. That's something that I consciously am reminding myself of when I read this book, right? This guy, nobody crowned him and made him the king of all style, right? He is sharing his wisdom and knowledge, and there are people out there who disagree with him, and you are also welcome to disagree with him, and I may disagree with him on certain points at certain times. But yes, he has biases. He's very much biased towards what he has seen and what he's experienced over time, which may be different for areas that you all might get into if you're interested in research or other kinds of programming. Might have different needs. I do think that a lot of the advice is phrased in such a way to be general enough to apply to a lot of situations. I do think he does a good job of doing that. Yeah. He does also assume that the people reading this book have, you know, a base level of programming knowledge, I feel like. And I know from the survey that at least some of you filled out that this class actually is skewing, I think, a bit more on the experience side than what I had intended, which is fine. I'm not upset about that. I'm just setting the stage. There are a lot of people in this room who are juniors and seniors who've got a few years of coding under their belt, and who I would naturally expect to maybe pick this material up a little bit more easily than somebody who's fresh out of 131. Although I really hope that those of you in here who are fresh out of 131 are still getting a lot out of this class. I think that it's still a good thing to read this book early. In fact, rereading this book for this class has been a very rewarding experience for me, because the last time I read it was 10 years ago, and my experience and my knowledge of these concepts has very much grown over time. So I think, you know, making a plan to revisit this book later on may be worthwhile as well. Sorry for the rant/tangent. But yeah, let's talk about that size of a function, since that's a point that he hammers home multiple times, right? We've all written functions that are quite long. Sometimes you've been told to do so. I mean, think about, it's kind of maybe not the best example in the world, but in 131, you don't even know how to write methods until you're halfway through the semester. And up until that point, you're just throwing everything in main. And then we tell you, well, actually, throwing everything in main is not a good idea, right? And so it kind of feels like we're pulling the rug out from under you a little bit. But that's just, we have to make some sacrifices in order to introduce concepts. I think it's unfortunate because it sort of starts to build up these habits. You're building up these habits early on in your programming career. And then when you learn new concepts, you then have to go back and break those habits. It's something that's happened time and time again with myself as well. And maybe you've all experienced this too. And so part of the goal of reading this book and going through this class is to hopefully recognize, that those habits exist and try to consciously be aware of them and get some practice on how to fix them up. One of the most important things that he says, though, and maybe this is a spoiler because it's like the very last part of the book. There's a very small section, or not the book, the chapter. There's a very small section at the end of the book that I thought was perhaps the most important section in the whole chapter that says, how do I write functions like this? I've just read all of these rules. It says functions should be small. Functions should have, as few arguments as possible. How do I write functions like this? And his answer is, I don't. I don't write functions like this. I sit down, I write code, I write long functions that have lots of arguments. And then I go back and I reevaluate my work and I make it fit this criteria. I think that's huge to hear the author of this textbook say that. It's something that I think we've already kind of discussed a little bit, but to see it printed out, to see it put in text like that is huge. And I wish that he'd put a big old glowing neon sign around it because it's a very important point to make. You're not necessarily going to change the way that you approach these problems, and your first pass of the code might look much the same whether you knew these rules or not. But taking the time to go back and apply these rules is the important part. Yeah. What else? I'm talking too much. I would like to hear from you all. Was there anything else from the chapter that you thought was particularly interesting, frustrating, surprising? Yes?
Well, so it seems like you were arguing that functions should be small, right?
Yes.
But then here that huge block at the bottom where he had rewritten the previous code and it's like, I find myself scrolling a lot to try to find functions.
Okay. Okay.
Where it's like, if it was just doing one thing, it was like one line, like if it was doing one line.
So you're making the argument that actually it might make things less readable, right? To have.
Well, it might have been just a really small example.
Mm-hmm.
Because there was so little code that was happening. Yeah, in this case, I thought it
made it less readable. It is true that functions, introducing more methods, more functions, is going to increase the number of lines that you have, right? I think that's just a fact because having the signature for all of those and then the spacing in between all of those is just naturally going to spread out the code. So I could certainly understand your point. I think that again, it's there's got to be a sweet spot though, right? Where like if you've got a bunch of functions that are super tiny, I can see your point. If you have a lot of functions that are giant though, it's kind of the same problem in the opposite direction. So where's that middle ground? I got to be honest with you, I don't know where that middle ground is. I think it's just going to kind of take some practice, some experience, trying stuff out and seeing how it works. And you are certainly entitled to agree or disagree with the quote-unquote readability. It's a very subjective metric. It's a very subjective metric. Thank you. Yeah, thanks for bringing that up. Anything else that you wanted that stuck out to y'all as you were reading through this? Do we agree with the general premise that functions should be reasonably small? That seems to be something that he said over. Is there anybody out there who's just like, I love my 100-line functions, I'm going to keep writing them? Is that a feeling that you walked away with? I'm probably going to keep writing them, right? The goal is not to necessarily avoid writing them, but to come back and fix them up later on. So I think if that's the one thing you walk away from this chapter from, that functions should be relatively small, I think that's a good takeaway. But let's dig a little bit deeper into some more of the details that were mentioned in this chapter. Some of the side effects of the making your functions small. One of the more interesting ones that I saw, that I have written down here in my notes, not a lot of nesting. If my functions are small, there's just not enough room for me to put 8 if statements inside of each other, right? Because that's too much stuff. That seems like a good thing to me. If we're talking about readability, I'm sure you've seen code where somebody's taken a bunch of if statements and loops and gone way out off the edge of the screen. And it's very frustrating. Even if you use good bracket style, you line up all your brackets, right? It can still be very difficult to understand a piece of code with that much indentation going on that's jumping back and forth. So I think that's actually an admirable goal. I actually still use that as a kind of a good rule of thumb. If I start to see my indentation level creep up 3 levels, 4 levels deep, that's a signal in my brain to say, well, I might be going a little bit too big here. And sometimes I ignore it and keep going on, but at least I have that, warning flag in my brain. I can come back later and try and do something about it. This idea that functions should do one thing. So if we're talking about the size of a function, really, should it be measured in lines of code? Not necessarily. It should be measured in what it's doing. There's a name for this. We heard Zach and Emma talk about this actually last week when they were here giving their presentation. The single responsibility principle. The idea that it should do one thing and do that one thing well. But the author also spent a lot of time talking about, what does it mean to do one thing? Because that's not always clear. And this concept of abstraction, which has already been mentioned a couple times, is very important to understanding this. This is something that we introduced actually in 131, but is a tricky concept. It's very tricky concept to wrap your brain around. So I'd like to spend a few minutes actually talking about what that means to understand what a level of abstraction is. How do you know what a level of abstraction is? Can you give, if somebody asks you to give an example, right? Or guy walks up to you on the street and says, "What's abstraction?" You say, "You're drunk, go home." No, what do you say? What's the answer? What's abstraction? It's a word that's used throughout this chapter. It's a word that we've used in 131. We'll continue to use. What do we mean by abstraction? Anybody got a handle on that? Yeah.
I usually like to frame it in the form of a comparison. Like, say in math, for example, just a simple comparison would be like you have the operation addition, and then you have the operation multiplication. Or multiplication is an abstraction of addition, because you're adding a certain thing that many times. And,
okay. And so, I see that a little bit differently. I think you pointed out an example of abstraction where multiplication is, in fact, repeated addition. But the fact that I'm using one operation to complete another operation is really what says abstraction to me, right? How do I perform multiplication? I add things repeatedly. How do I add things, right? I, take 2 numbers and add them together. So that's where the abstraction comes in. I've defined an operation that I want to perform, in this case multiplication, but then when looking at that definition, there's another part of that that needs to be defined. That is abstraction. The classic example, I think the 131 example of this, and sort of the classic computer science example of this is cooking. How do I cook stuff, right? I have to gather all my ingredients, prepare them, and then usually apply some form of heat, right? So what are the abstractions? So cooking is made up of gathering ingredients, preparing them, applying heat. What does it mean to prepare them? It means I have to chop them or blend them or, whatever the case may be for the recipe that it calls. So preparing ingredients is a broad abstraction of doing more specific things, chopping, slicing, whatever the case may be. So if we think about this in computer science terms, right? Start at the program level. What is the program doing? This program is, sorting a list of numbers. right? Okay, so how do we sort that list of numbers? Well, first we partition the array in half, and then recursively drill down until we get to a single element, and then merge it back together. And then look at all those different pieces, right? Break those down into individual functions and connect them all back up to accomplish the original goal. It's another thing that's very difficult. It's actually still kind of difficult for me to recognize these abstractions and how to apply them. It's hugely important, and the only way you're going to get better at it is by practice. By practice, practice, practice. The example that he uses in the text is with those two statements. It's pretty good. It's a pretty good example. But there are other techniques that people have used to identify abstractions. Find one that works for you and stick to it. His example is a little bit dated. He's definitely been programming a lot longer than I have, or a lot of people have. So some of his references are a little bit dated. Are there any questions about abstraction or any confusion around abstraction? It's such an important concept, especially when dealing with functions. And we're kind of putting the horse before the cart a little bit here when we're talking about abstractions. I think it's also important to know that the reason that functions exist and the reason that we write functions is to put abstraction into code. Like, that is the whole point of having functions. So a lot of times, I think, well, especially, I'm speaking in my own terms here. When I'm writing code, I'm just like, I need a function to do this, and I don't even think about the why necessarily, right? I don't think about what's the abstraction that I'm representing with this function. It's just like, it just feels like I need a function here. It just feels like this is the method that I need. Whereas it really should, kind of be the other way around, or we're trying to train our brains to think the other way around. What are the abstractions? And then let's code up the functions based on those abstractions. So then getting back to this idea of whether or not you know the code is doing one thing, if you have an idea of what the abstractions are, each abstraction then is going to be your one thing. The one thing that a piece of code is going to do is an abstraction. Awesome. He mentioned some stuff about switch statements, which was kind of interesting. I don't necessarily think that was the most interesting part of the chapter, though. And using switch statements, is not something that I personally do on a regular basis, although you could argue maybe that's something I should be doing more of, perhaps. How many of you are using switch statements all over the place? Yeah, that's about right. It's just not a common programming mechanism. So I think that was also one of the more conceptually dense parts of the chapter. Actually, he was talking about using polymorphism and creating an abstract factory. I've had more than one person come up to me about that question and say, I was looking up these terms and I'm still not quite sure what that section is saying. That's okay. That's all right. I think books like that should be challenging. They should introduce concepts that are new to you. If you had to look them up, great. That's fantastic. I think that's a good thing to be doing. If you still don't fully understand it, that's okay. You'll get to polymorphism and abstraction later on in your programming career. Well, we're doing abstraction now, but you'll get to polymorphism later on for sure. So there's plenty of other stuff for us to talk about, like arguments. Let's have a chat about arguments. Spent a very good portion of the chapter talking about the number of arguments that a function should have. Specifically, the ideal number being 0, right? None. He makes a claim that no function should have more than 3, and even 3 is pushing it. How do you feel about that? Does that seem like a reasonable distinction to make? Did you buy his arguments as to why 3 is the absolute upper limit? Does anybody feel very strongly against it and want to argue that that's not a reasonable thing to expect? Yeah.
I mostly agree with the reasoning, but for like constructor, I would say it would be kind of annoying and time consuming to like make a new object.
I think that's a good point. Yeah, for a constructor, remember the role of a constructor is to initialize all of the instance variables that it contains, right? I think we'll see a little bit later on, however, when we read the chapter about objects, and again, I'm kind of spoilering that chapter a little bit, but just like he's going to argue that functions should be kept small, he's going to also argue that objects should not be these massive things with 100 instance variables in them either. So, in that sense, it kind of reduces the need to have huge parameter lists as part of your constructor. But yeah, I think it's still a valid point. If you have 5 instance variables in a class, the constructor's got to make sure they all are set. That's its job. So that could be perhaps an exception to this rule. I don't know. He doesn't actually touch on that specific example. Yeah.
I actually found it interesting. Whenever he was talking about the number of parameters that you should have, he mentioned that if you're using like Cartesian coordinates, that having 2 entries instead of 1 is actually more clear. So that made me think that the argument that he was trying to make isn't necessarily to reduce the number of parameters that you're using, but instead keeping them understandable. Where if you're doing if you imagine some case where you're performing some mathematical function that requires a lot of inputs, as long as those are clearly defined and well understood within the context of the problem, then it doesn't make that big of a difference.
Sure. And do you remember why he said that he thought 2 parameters was acceptable for? There was a specific reason he gave as to why Cartesian coordinates.
Because it was a natural understanding, where if you have a point, and that point is written in Cartesian coordinates, then you would expect it to have 2.
Not just the natural understanding, but the order. He specifically mentioned order, right? Like X always comes before Y when I'm talking about coordinates in a 2-dimensional plane, right? Like that's just how it works. That's how human beings talk about these coordinate systems. So especially when dealing with multiple arguments in a function, if there's some kind of natural order to the way that we expect them to appear, that's a very understandable way of going about it. And your example of a math function, I think, is an interesting one as well. I think there are certainly math functions out there that have more than 3 arguments in them, right? It's very common to have more than that. And the suggestion that you should break those formulas up into different functions specifically to keep the argument list shorter is a little bit ludicrous in my opinion, right? Like, it doesn't make any sense. It doesn't make any sense to do that. When would you ever compute half of that formula versus the other half? It just doesn't match my experience. I think this is a case where his bias is kind of showing through. He's not used to working on, I don't think, research-oriented applications that are doing these kinds of arithmetic operations. I certainly think that would be an exception to the 3 arguments rule. That is one that I regularly break all the time and don't feel bad about. I do, though, think that his 3 arguments max rule, for the most part, does make sense in the general case. There are exceptions, but I think in the general case it is a good rule to try and follow for the reasons that he explains. It all kind of points back to the crux of the chapter, which is that functions should be kept small and they should be doing one thing. The more arguments that you've got, the less likely that your function's actually doing one thing, right? And doing so in a way that's not confusing to the reader, confusing to the people reading. I did really like how he broke down single argument functions into categories. He said they were either asking a question or transforming something. I thought that was a really useful thing to think about, something that I still use when I'm writing functions. What is the question that I'm asking here? What is the thing that I'm transforming with this function? Those are good questions to ask yourself when you're evaluating your own functions. And of course, a nice thing you can do this almost feels like cheating, right? I read this, so you read this whole section about how 3 arguments or less, and then the section right after that almost feels like he's cheating. He says, if you need more than 3 arguments, well, maybe you just use an object. Take some of those, pack them into an object. There you go. Now you've eliminated all of the extra quote-unquote arguments that you had before. How do you feel about that? Is that cheating? I don't actually think it's cheating. I actually think it's a reasonable suggestion. I think it's something that seems intimidating and perhaps unnecessary to a lot of people, but something that I wish I would see more. The number of objects should be relatively high. I would much rather have a relatively high number of smaller objects than like 2 objects that are 10 miles long, right? Notice how easily and willingly the author is to making new objects. It's not an ordeal. It's not a massive task that he has to perform. It's just like, oh, I've run into this problem. Let me create an object that'll solve it. That'll make my life easier. That'll make things cleaner, more organized. I think there's kind of a stigma that I've seen around, adding more objects to a project, but if it'll help keep things organized and clean, then you should absolutely do it. Absolutely do it. Any questions or comments about the number of arguments before we move on to some other stuff? I guess one more argument-related thing that kind of deals with the next topic on my list is output arguments. This is something that I wouldn't have expected many people to be aware of before now, although you probably used it or perhaps seen it before. What is an output argument? The text doesn't even describe it. This was something where I read it the first couple times it showed up in the text and was like, what the heck is he talking about? And then after I read it a few more times, I was like, oh, that's what he's talking about. And yeah, I've done that all the time. I've seen that all the time. What is an output argument? Is anybody familiar with that concept, or did anybody decipher what that meant in the text? Yeah.
I looked it up, but I wasn't sure about it. But I think it's when you kind of transform the argument, and instead of returning something, you're just changing the argument. Yeah. So it only works with a certain type of arguments. I can't do it with ints or doubles. It has to be an object. So if I take an object, I pass it in as an argument, and then I manipulate that object, right? I change the object that was passed in. So the output isn't returned. The output is just the fact that that object has changed. That's what he's referring to as an output argument. I think he could have maybe phrased that in a slightly different way, or at least taken a couple sentences to define exactly what he meant by that term. But looking it up is okay as well. That is absolutely a bad thing. Why? Why is that a bad thing? Think about what that would happen. Think about how you would feel if that happened to you. I'm calling a function, I'm passing in this object. It's being treated as an output argument. So what does that mean? After the function is over, the object that I passed in is now different than it was before? That's surprising. I feel like that's surprising. That is a surprising outcome. I don't expect my arguments to be changed throughout the course of the function. Changes that occur should be passed through the proper channels, in this case a return statement. If I pass an object into a function, I expect that object to be the same when it comes back out. Do you agree with that statement, or do you disagree with that statement? Do you think, maybe not. Maybe that object will be different, and that's okay. Anybody have feelings about that? Personally, I think, we have return statements for a reason, right? Return types for a reason. We should use them for their intended purpose. We actually, I feel like, do a reasonable job of this in 131, where if we expect you to return an object, we expect you to say new whatever, right? Make a new instance of that and return that, right? Although I'm sure you could probably also find some cases where the objects are modified throughout the process of the function as well, if you looked hard enough. It's actually a form of a side effect. What's a side effect of a function? Output argument is a form of what I would consider to be a side effect. What's a side effect? In the general case, yeah.
It's when your function does something
Yeah. So I read the name of that function. That gives me an idea in my head of what that function's doing, right? Anything that it does that is outside of that is a side effect. Anything that function does that is outside of its stated purpose, whether I get it from the Java doc or from the name of the function itself, is a side effect. And we should be writing functions that do not have side effects. They're unexpected. They're unexpected. We then have to play this guessing game with functions. Is this function going to do something that I'm not aware of, or is it cool, right? Is it going to do exactly what it says it's going to do? Or maybe even worse, it's like this function says it's going to do X, and I run it, and it does do X, but it also does Y, and I'm not aware that it does Y, and now my program's not functioning, and I'm like, what the heck's going on? I don't understand, where's this problem coming from? I thought all I was doing was X, and now I'm seeing X and Y. That's a classic example of a side effect and why we should try to write our functions to avoid side effects. Again, very difficult to teach somebody how to do this. It's just something we have to make people aware of and then get practice, get experience writing functions in such a way as to avoid side effects. Cool. So we're almost at the end of my list of topics here. Just a couple things to wrap up. There was a section in the chapter about exceptions, which was, I think, a good topic. There's a whole chapter about exceptions, and I want to talk to you about exceptions specifically coming up it's on the calendar somewhere. So I'm going to kind of put a pin in that for now, unless any of you really want to talk about it today. I'm going to leave that for a little bit later on when we get to that chapter. The main thing so something else at the end of the chapter, and something that I see a lot of, and I'm sure, and something that I've done it. Not repeating yourself. Don't repeat what you have already done. That is we teach people this in 131, right? This is something that we teach people in 131. And it still continues to happen. And, again, it's not necessarily a bad thing that it continues to happen, but at some point, you really got to go back and you got to take care of it. You got to get rid of that repetitive code. Get over this idea of, oh, this for loop worked really well, so I'm just going to copy paste it and use it again here. I fall into that trap all the time. If you're trying to do something quick and dirty, it's not necessarily a bad thing, but the proper thing to do is to wrap it in a function. So with that in mind, I'm going to show you actually some tools that you can use in Eclipse to help you with this. One of the main takeaways from this chapter is that we should probably have a lot more functions than we usually do, right? We write functions that are long, have lots of arguments perhaps, and we really should be writing lots more functions that are shorter, have fewer argument lists. So with that in mind, we can actually have Eclipse create functions for us. So I don't know if this is a good thing to do or not. I'm actually going to have you think about this in just a second. This is the dice simulation that we were working on Monday. Let's say that I see this for loop here. I'm like, that should go into a function. I want to put this into a function, right? That's what I want to do. So I can highlight this section of code. I can right click and go to refactor, and there's a thing here, extract method. So if I select extract method, it's going to ask me to give it a name, and then it's showing me the parameters. These are the values that this method needs to function, right? And so just to keep things simple, I'm just going to call it foo. Again, is this the right method to make or not? I don't know. That's something that I'm going to ask you to think about in a little bit. But I'm just showing you how you can use Eclipse to help you out here. It's showing us the method that it's going to make for us. I hit OK, and now you can see that it replaced this line with a call to a method called foo that I just created. And if I scroll down here, you can see that the code that I had highlighted is now in its own separate method with the parameters and a return statement added for me on my behalf. This really simplifies the task at hand, which is trying to reduce
the sizes of our methods by making more of them. Actually, you know, one argument you could point to right away that says this maybe isn't a great method is the fact that I'm still at 4 input parameters, which is, you know, we're trying to avoid that situation, right? Trying to avoid it. So this is a great tool that you can use to help you refactor once you've decided that you want to try and do that. And so, as you might imagine, I'm going to give you an exercise. Actually, I'm going to have you look at your dice simulation. There's 2 ways you can go about this. If you were here on Monday and you got your dice simulation in a spot that you feel is pretty good, you can go ahead and use that. There were errors, so if you didn't get a chance to correct all of the errors, I actually made a branch on the repository, right, with a corrected version using the variable names that we talked about in class on Monday. So if you want to grab a good copy, you can go to the, oops, what's going on here? You can go to the repo and do a pull. That's step 1. Mine's already up to date, obviously, because I've already done this before, but yours would, you know, pull down the information. And then how do I switch branches? Checkout. I'd say git checkout, and the name of the branch is called functions. The nice thing about doing this is, if you do this on the repository that is currently loaded up in Eclipse, it'll automatically swap out the changes right in Eclipse. And the Eclipse keeps your repositories in a folder called Git that is usually in your personal directory. It's where it usually goes. So if you need help locating it, I'll be around. Or, I mean, you know, there's lots of other ways. If you weren't here on Monday, obviously just grab the repo and set it up in Eclipse or IntelliJ or whatever you'd like, and switch to the functions branch. You're also welcome to use, like I said, the code from that you wrote on Monday. And what I want you to spend the next 15-20 minutes doing with the help of your friends and neighbors is, you know, this is all in one main method. That's terrible. Now, to be fair, it's not really, you know, the student's fault that it's all in main. This is very early in the semester before we've even talked about functions. So we're basically telling people to do everything in main, right? So I don't want to see all this code in main. I want to see functions. I want to see functions in here. I want you to take a look at this code and try and decide where the levels of abstraction are, make the functions, right? And see if you can clean this code up. And something else to keep in mind, if it would be useful for you to create an object or two to help you with this, please do it. Do whatever you need to do, right? This is your chance to clean this code up and try and make it as reasonable as you can. It's tricky. This is tough. I expect you to struggle. I expect you to get into some situations where you're unsure of what to do, but it's good practice. And I'll be around if you get stuck. Although, talk to your neighbors. You've got lots of people around. And so we'll do this for the next 15-20 minutes. Get as far as you can. I'd be very surprised if anybody was able to crank out a perfectly spotless version in that short amount of time. But get as far as you can. We'll have a little conversation about it and then chat about the homework assignment after that. Okay? Let me know what help you need. Something first. I'll be back when you are.
USB-C cord and it wants to turn like that. If they might have either, yeah, the USB-C to USB. Okay, cool. We have it. We may have portable charging.
Are you used to it?
Yeah, I'm just saying. I had it in the room one time. I just lost it. I think I checked. Oh. See, that's a good question. Yeah. Actually, very creative. And the answer is
Yeah, so I let's get you the charge on the other side of the lake on It's good. It's surprisingly it's a change of speed, yeah. So we want to put it down. The other one is
I have that, so once you have it,
it already pasted it. Not really watching. Next. So it's actually showing you the branches here. If you want to function, master code doesn't run it. If you want to function,
Right, exactly.
check that, yeah, and then next. That'll be the same process that we
honestly, I'm here. After spring break, I'm literally not doing nothing. It's just terrible. I have man work up there. I'm not trying to learn. See, that's what I'm trying to say. I know that. She.
Finishing out strong. Stay here for another
How do you I made a package.
there's some, it means there's some, could be that.
Wait, what? You got an error? How I got an error?
Yeah, so it's
Bro, I gotta go fix it. Oh my god. What are these names? Oh my god. Bro, give me a file. He has it. Exactly, run me there. Oh my god. Okay, how do you find a replacement? I'm sick. I mean, I could have came to class if y'all trying to be sick.
Figuring anything this out? I'm trying to do this whole extract method thing and I cannot figure out. So do you think I did too, but he's asking me. I don't really take it. Are you intelligent? Yeah. Yeah, exactly. Oh, you mean? Yeah. So if you have any new ones, I would just have to do the actual. Oh, I didn't. What he highlighted to just make it easier. Yeah,
Why you sitting in the front row? If you go only leave it early, it's not really in the front row. Come on,
Yeah, it would make me think that I'm not highlighting it enough.
What's going on?
So when I try to highlight this before, and I try to go to the back, there's no extraction in that. Which makes me think that, does it just know that I haven't highlighted like enough or something?
No, I don't think so. To be fair, be safe before we go. Oh yeah, like more safe. I don't know if that means
The Git Checkout actually wasn't working.
Oh, you kind of actually what? That could have something to do with it, maybe.
Okay.
No,
So try to just check out until the
So you might not be in the right place. It looks like you're full.
I pulled.
There were updates.
I mean, they like store the decks and the correct. The rules is
When you highlight it,
It shouldn't matter what you include. I mean, if you should just offer for you to do that. There it is. Yeah, so I guess it does matter because now it's letting you.
and it counts how many of the same.
Interesting. I'm not sure why.
oh, what I got.
Not somewhere else.
This whole thing is just like going through and printing on all the decks.
Yeah, you might have to. You can always do it the manual way too. Right?
So I tried to extract it. So it says things there's not going to make the match out.
Where would it be on the map?
31.
Yep.
So I tried highlighting this instead of this one, including the frequency of some modification, because that sounds like checkout. And now it would get pulled, and I went to.
I don't think so. I think just get.
I'm not sure if you're
There you go. See, it's telling you new branch.
This is right.
Git Checkout. So it's saying that you've got changes here.
Oh, Jesus.
Once I
That was an office.
auto replacement.
The double-digit office.
Yeah, some rules do not buy.
Sorry, no.
Yeah, so if you go to the Git repo and then you can check out the new range, just automatically like
I understand. I understand that. So literally any parameter that they use in the for loop, they make it into arguments for the.
You need to be in the right direction. So
Yeah, you print out nice for rule.
And then they just slap it on and they slap the for loop.
So you're not the right direction. Looks like you were.
I mean, maybe. I think it's okay. I don't know if I'll say now, but like for the group.
Oh, yeah. Oh, you ready?
It sounds like so many people use the clothes.
Oh, I see. I bet it's yours. Yeah. So if you do it again, hold it.
Here that they are. Yeah, I just checked.
You take this out on Monday. You got it on Monday. You do again, hold.
I did it the way he tried to. So I did it from the command line, but it wasn't working for him. I hear some pretty much tiny and he shows pictures. I would say just like, oh yeah. So yeah, I found that usually it's in like users and then your personal. So whichever one you can. Oh wait, it's a folder called Git. Okay. I guess users.
Oh, so we have to make it look nice.
I didn't know
I mean, you can make objects that has
I don't know, man. I did like a really small one. So I just did this little thing because this one's really easy to read. It's just you're just printing the frequency of songs. So if I just highlight that, that's easy enough. All I have to do is call it.
I mean, you already copy pasted, so I'm not sure how that's going to get. Regardless, you're in the right spot.
Like watch all of the 131 videos. So I'm like, exactly. Like, Eric, can you put it? I'm a little bit lost. That's hard. Where are they? I do read the book, but I pour so much time into that just to make sure I understand it. And even at the end of that, I don't understand half of it. You're taking this class for the points of your major. I'm minor. So yeah. How are you enjoying your time watching?
Well, it's clearly still very long. I think there's lots of pieces that could be checking for the Yahtzees. Yeah, it's going to be another one. Maybe even the.
You've got plenty of time.
Yeah. So I still think there's several. I think a complete solution is probably have pieces.
So what's your age?
I'm psyched. But I've got mine. Yeah, the hard sciences were a little bit too hard for me, so I went to a softer science.
yeah, I'll like it make
money.
whatever you do.
What do you think you're gonna do with that?
Yeah.
Looking forward to having to take out 3 issues.
Ooh, okay, yeah, usually we should have
Also, top 3, the good thing is that if you can code straight in top 3, you get credit. You get credit for how safe it is. So if you wanted to have right. I hope he gives us a really good talking about it. I miss those days. High school, they like give each other grades in the group project kind of days. Yeah, I think Eclipse does importing things a little bit differently than
Okay, we've got about 18 minutes left, so I know that some of you probably still work on this. That's fine. For some of you, this turned into a little Git review session, which is also fine. Actually, it's good practice. But I did want to spend at least a few minutes chatting about this and then also chatting about the homework assignment before you get out of here today. So this is tough. I got a lot of good questions about, you know, where the different pieces are. Again, I think a good way to approach this is to start, you know, with the program as a whole, and then think about the pieces that program is broken up into. So this is a program that is simulating dice rolls, right? But it's actually a little bit more in depth than that. And so I guess I'm interested in what you saw the sections of this code to be. So what are some targets for methods? If you just had to explain in English, what are some targets of methods that you were thinking about? What are some sections of the code that you thought should be sectioned off into methods? Yeah.
It was line 24. It's like a few lines and ends with frequency of sums. Modifying that, turn it into a method.
So this thing,
yeah,
this whole section that I got highlighted here. So this is the one that checks to see if they're all the same. We call that Yahtzees, right? And then this is also updating the frequency of sums. I think we need to be a little bit careful here. Remember that one of the targets of our methods is they should do one thing, right? They should do exactly one thing. So this is a case of, I think, perhaps two things. I am checking to see if they're all the same, and I'm also updating how many times I've seen the sum. That's actually kind of two things, I believe. So I do think this is a good target, though. At the very least, you know, this Yahtzee checker, or whatever the case may be, is a good target for refactoring out into a method, perhaps.
And so, you know, we can try to do that. Something else that I think should be, whoops, what did I do? I hit the wrong button, I think, sorry. Extract method. Here's the same problem though. I know that text is well, this text down here is not too small for you to read. Here's the same problem that we were running into before though, where the number of arguments being suggested is still kind of high, right? Any ideas what we can do about that? Yeah. Took in a single array and returned a Boolean. I really like that. So we're actually kind of deviating from the suggestion here and maybe doing things a little bit more manually, right? What's the output of this? It's whether or not they were all the same, right? It's whether or not they were all the same. And so that really kind of changes the effect of this method. You can still use this extract method to help you, but you might call it like are all dice the same? I don't know. That's a kind of a mouthful, but that's par for the course for what we've been talking about. That still doesn't address, you said it takes in a single array, so that does actually address the number of arguments, right? We don't need dice per roll. We don't even need the full 2 dimensions, right? We just need 1 row from the array. We don't need this counter. We don't need this loop variable, right? We don't need any of that. And so we can, you know, try to get rid of these, although I think we have to wait until after the fact. Can I? Yeah, it won't let me. It won't let me remove them from this list unless somebody else figured out how to do that. I don't think that it will. So I can still extract the method and then try to change it manually. We need a single int array as the input. And calling it like a roll array is not necessarily a bad name. I don't need these variables. Changes this now to be just the roll array with a single dimension. So notice that there is still some manual work that has to be done, right? And now instead of an int, we're returning a Boolean. So if I get here, I'm just going to return, actually, we can switch this up a little bit. Not equals, return false. And then down here, if I make it return true. And then I need to switch this to what? This would be roll array.length, I think. So notice there was a little bit more work than just simply extracting the method and calling it a day, right? It took a little bit more work than that. In fact, we still have a problem up here with the method call. With this method call up here, we still have a little bit of trouble because it's now expecting a single array, which we can get. If we say dice array at I, that should get us, I think, the right roll. And then we would need to wrap this in an if statement, I believe, to check the Boolean and increment the counter accordingly. What was the name of that variable? Dice all the same count. There we go. That is one refactoring, right? One refactoring of taking a chunk of code, abstracting it out into a method. I like this method. If we can take a second to pay attention to this method, it's clearly stated what this method does. It's saying all the dice are the same or not. I look at this method and I can tell from the name of the method alone, it's probably going to return true if everything in there is the same, and it's going to return false if they aren't. And then it does exactly one thing. You can see the indentation level only goes 2 layers deep, right? That's another good sign, correct? I think this is a good method. It's certainly an improvement. It's certainly a step in the right direction. Yes?
I was just wondering that if it's a good idea to include method comments while you're writing method, or like are they unnecessary?
Comments are always fantastic to include. So, I mean, the common ones are like JavaDoc comments. We're going to talk about JavaDoc on Monday, I believe. That's the next set of readings. We're going to talk about comments and formatting. That's Monday's topic. But yeah, absolutely. Always a good idea to include comments. We'll have a conversation about that in class next week. Was there another area that you all highlighted as a place where we could try and extract a method here? We probably have time to do maybe one more. Any other areas that you identified? I mean, the one that I highlighted earlier, like this, I think is a good target. What is this chunk of code doing? It is doing one roll, right? It's doing one roll. So if I use extract method here, what's going to happen? If I try to do refactor and extract method, it's going to try and give me these parameters again, correct? So let's think about this for a second. Do I really need all these parameters, or what do I really need? I need a method that will simulate a roll for a certain number of dice and then give me those rolls back as an array, correct? So using extract method, while certainly useful, is not a tool that should be done blindly. It's something that you would need to think about. Roll dice. I want a method called roll dice that's really just going to take in this value, this first one, dice per roll, and then give me back an array that's got that many dice simulated in it. Does that make sense? I think that's a great target for something to be done here too. So get rid of all of these arguments, right? Boop, and then return the int array. Notice what that means. All this stuff relating to the sum, that's not here. That's a good what's the word I'm looking for? It's a good reiteration of the concept of a method should do one thing. What's this method doing? It's rolling dice. It's not summing dice, it's rolling dice, right? I'm rolling the dice. I'll worry about summing the dice up somewhere else. That's not my problem right now. That's not what this code needs to do at this current moment in time. Correct? So all I want to do is stuff related to rolling dice. So I can get rid of basically everything else. Even printing. Even printing. This method is rolling the dice. And this is something that I think kind of bothers some people a little bit. Printing is an action. Printing is something that we perform. I would consider that to be in its own separate method in a lot of cases. I really dislike having methods that are going to perform an action and print something in the same method. What if I want to do that action without seeing the output? If they're linked together, I don't have an easy way to do that. So even the printing, I feel like, is not necessary here. What do I need to do? I need to make an int array dice. And then stash the die roll in there. So here's another method that I feel like is pretty good. Notice again, the indentation levels don't get too deep. It does exactly one thing. It rolls a set of dice. I think if we were talking to the author of the text, he might argue that these methods are maybe even still a little bit too long, and maybe could even be sectioned off even further. There's definitely some wiggle room. There's definitely some room for debate as to how much abstraction you should be including here in your code, but at least we're making progress in the right direction. So I was talking to a few people about this. You know, by the time you're done with this code, I would expect at least a half a dozen functions, if not more. If you do this properly according to the rules outlined in the text, I would expect at least half a dozen functions for this one. Which leads us to then the assignment. Here we go. We got 5 minutes left. Let's have a little chat. There's 2 parts to this assignment. The first part is basically what I was just asking you to do, but with a different chunk of code. I'm giving you a chunk of code to work with, and it's not that great. It's kind of ugly. Some parts of it are very ugly, and so your task is to fix it up. You've got a pantry class, which represents, you know, a container of foods that you've got available, and then you've got some unit tests for this class. The reason that we gave you the unit tests is actually to show that if you do this correctly, it's going to end up breaking some of those unit tests. When you go through this code and clean it up, it will probably result in some of those tests failing to work, or maybe even all of them. And that's okay. In the real world, we'd then be expected to fix those up. I'm not going to have you fix the unit tests, so if you break the unit test, that's all right. It's just something I want you to be aware of. You don't have to fix them. We're going to talk about unit testing a little bit later on, so you'll get practice writing unit tests in the future. I want you to fix up this pantry class. I want you to make it look nice. I want you to follow the rules as outlined in the text to the best of your ability. That means not just what we did today, but also what we did on Monday. Variable naming, method naming, as well as extracting out methods, making the methods appropriate sizes. Those are your 2 main goals. Part 2 is one that I hope is going to be a little bit more fun, a little bit more interesting. I want you to find an open source project and write a little critique of it. I want you to critique the variable naming and the methods, the functions. Not of the entire project, that's probably a bit too much. I want you to find one class, basically, right? Find a class. Don't do the whole thing. Ideally written in Java. So go find an open source project online, find a class that's got some interesting stuff in it, and write a little critique. Some things to keep in mind. You do want to find a class that's doing something a little bit meaningful. So this is a kind of a rule of thumb. If you have less than 5 variables and functions in the class, I'm not necessarily going to give you a 0 on the assignment outright, but I do want you to have something that's a little bit substantial, right? I also want you to find something that gives you something to talk about. I don't want to get a critique that says, this class is perfect. There's no changes that need to be made. The end. That's not what I'm looking for. Find a class that needs some work and tell me why you think it needs some work, right? Tell me what changes you think it needs to be made. Find some code that you think needs to be revised. It will not be hard, I promise you. It will not be difficult for you to find code that needs some help. As a helper, as a pointer on where to look, actually you can go to GitHub. If you click this link, it takes you to the trending page on GitHub, and you can search by language. So it's already selected for Java. Go through, these are all open source projects that you can take a peek at to see if you can find something. You're not limited to this. If you want to find an open source project somewhere else, you're more than welcome to do so. I just wanted to give you a place where you could start looking. So that's part 2 of the assignment. And I think that's it. If there's any questions, I'll stick around for a few minutes. Otherwise, thanks for the discussion today. Have a great week, and I'll see you back here on Monday.